guys, so I'm doing a video on logs and graphing transformation and stuff. So basically these are your rules for logs. Right here you got k, which is right here, your ups and downs. Remember the parentheses, that's always important. You have to first do the log part, which needs to be boxed in right here. Then you do the rest. X minus h. If it's in this fraction form, you got a vertical shrink or compression. X minus h. Actually, that's not related to this. And then greater than 1, vertical stretch. Negative is your reflection across x-axis. That goes there. Then this is your key log part. The minus h is your ups and downs. Moves right if it's minus h, plus h. Moves to the left. So now, we're going to be doing a problem here. I'll be doing this one and then explaining it. And then we'll just do some more practice. So let me finish this one and then I'll show you guys. Hello guys, I'm back and I've done this. Obviously my handwriting is not the greatest, but I'm just gonna go over this problem. And so basically this is what you start out with, and obviously I should be asking this, but try to do this on your own and pause the video before I show you. But I'm just gonna go over the basic stuff and then we'll actually do it together. But so we got f of x log 1/2 parentheses x plus 3. So the important part actually that even I sometimes can forget here is that do this part first. Before going anywhere else, do this part. You need to do this and then you can go to this plus 2. There's a reason why it's in the parentheses. This whole log function is this first part right here. I'm just erasing this now. So yeah, that's your main first part. And so now what we do is basically when you're trying to do like transformations and stuff here, you have your range, which is always negative infinity to infinity when you're talking about these functions. This is the exact opposite, the inverse of a exponential function. And then the transformations, when you're doing quadratics or doing some sort of any function type of thing, they have the similar setup of this. And obviously when you're looking at this, this would be your x minus h, this would be your k. K, that's your up 2, then minus 3, because x equals negative 3, that's your left 3. And if you graphed it, you pretty much can get that exact same thing. You can see that your normal would be like this kind of thing, but obviously it's been pushed that way and it's moved up a little bit. So yeah, that's how it's been changed. Always in your table here, you want to add certain things. I use these things because obviously the question will ask that sometimes, so you want to include those so you can do other questions as well. So always think ahead. You got your asymptote here. This is a line for the asymptote because you know it's never going to reach that number. Domain, you pretty much know from asymptote to your infinity will always be your domain. Asymptote you get from your x plus 3x, anything x minus h, that kind of number when you're solving. Oh yeah, I have to write that there is actually a y-intercept. I didn't solve for that, but obviously you can. So 0 would be here. You would have 0 plugged in for x, so then we'd get log 1/2 3. Sometimes you need to use the base change formula, which is for this case when we're plugging in a 0 for x to find out the y-intercept. Sometimes calculators don't have that, so then you do, so log, you'd use the base 10, that's your common base, but I obviously wrote it out, but you don't really need to, that's always your common base for log. So what you do would be, so 0, so it'd be log 3 over log your smaller one, log 1/2. Then you solve that, and then you add the plus 2, so that you can get your final answer to find out the y-intercept. So I'm just going to do that in my calculator here. I'm going to show you. Move this up a little. Okay, so this is my TI-84 Plus CE calculator, so basically your buttons here that are critical for logs would be your normal classical log button. This is with base 10, but obviously there are calculators that you can put whatever base. I need to find out how to do that. And then you've got this, which is your natural log, which is for E. So I'm just going to do for this question exactly what I was going to put. So I'm putting in log 3 parentheses that divided by log 1/2. Put that in. We got our answer, and obviously we have to add in that 2 because that comes next. And you've got this answer right here. So let me see. I'm going to try doing fraction. Okay, no fraction. So I'm just going to round this to whatever your teacher or whoever or whatever the sheet says to do it at. I'm just going to round it to, I think I'll do it to hundredths. So I'm going to do that. Okay, guys. So obviously I just wrote it in here 0, 0.42. Obviously, always when it says intercepts, write it in coordinate form. You have your x-intercept, which I just found with the graph. Simple one there. Domain transformation, asymptote looks good. Interval increasing or decreasing. So you find that out based on your base. If it's a fraction base, then it's decreasing always. When you have a normal whole number, or you could say like integer, or actually it can't really be integer. It has to be a natural number or a whole number. It actually can't really be 0, so natural number. If it's a natural number, then it's increasing. Well, I mean, there are reflections and stuff, but we're just talking about like normal bases here. And then we've got arc, which actually is, you can see all of it's like that. So that's an acronym for, what was it? So it's the average rate of change. You're trying to find the slope using these two numbers. That's your y2 minus y1 over x2 minus x1. That just helps with when you're looking at a certain points, you're just looking at a certain like range of the points. You don't want to look at the whole thing because obviously the numbers can start getting insanely big near the asymptote, and when you keep going, so you just want to see that certain range, especially that's critical when you're doing actual real life situations. So basically the asymptote here, that's why I used these two numbers, x that. So then 3 minus 0, and then that, see here, the work, then we get this answer. And then end behavior, f of x would be also known as y. So as x is going to -3, while it's going that way, it's going up, which is your y, to infinity. Then you have here both of these going to negative infinity. It's going this way and it's going downward as well. So that's why negative infinity, negative infinity. So that's how you get that one. And now I'm just going to do the next problem. So let me just do it here. So domain, we're going to find that out. So this would have to be, so this one here has a multiplication actually, 2 times the log 3. So you're trying to find your asymptote based on your minus h, no minus h, so this is basically 0. So then this domain just goes to 0 to infinity, and your asymptote x equals, always put the x equals because your asymptote is a vertical one, so it's x. X equals 0. I just draw the line here so it makes it easier when graphing. Just a dashed line to show the asymptote and represent it in my graph. Interval of increasing or decreasing, you can tell the increasing by that small base of 3. Hopefully you can see that. It's kind of hard to see on here. But yeah, that's your base of 3. So with the base of 3, that these will be easier to see. But this one is a base of 3 here. I'll just show you the question before I actually. 2 log base 3 and then x. I added that extra stuff in the end. So that's your base of 3. So I already know that's a increasing, and that's going to 0 to infinity because when you're doing intervals, you're obviously doing it with your domain. So x to infinity, it's not going to ever change to decreasing. It just goes one way. X-intercept, there's a way of finding that out if you can't find it by just graphing. I'm just going to graph and see if I can get it. Usually, if it starts at 0, always going to be these are always going to be on the right side. So you usually can choose 3 points, and you want to choose a 3 right after the asymptote to the right of it. So I'm doing 1, 2, 3 because also actually that helps me out with this question as well. So I'll just do 1, 2, 3. And then 1, 2, 3, so then we have this here. So 1, when we put this in, I'm going to take this out. 1, when we put this in, log 3, 1. Always the rule with 1s when it comes to log means that the y will be 0. But remember, you have to multiply that 2, but even multiplying 2 times 0, that's 0 still. Then 2 to a log 3. Now, if you're having trouble and you can't find it because it's just that odd number, you can always use your calculator and use that base change. So I'm just going to do that. So what you have here is you use log 2 over log 3. Over log 3. Oh shoot, I messed up. There we go. That, and you have to remember there's still that times 2, if you can see here. Times 2. So with that times 2, you're going to need to add that into it. So that's what you get without the times 2. Times 2 that. 1 point, I'm doing to the hundredths. 1.26. And just approximately on your graph, it's not going to be perfect. Then you've got your 3. That would mean 3. 3, 3. That's another formula kind of thing. That means it's 1. 1 times that, 2. Seems accurate. It's increasing. So it sounds like it's correct. See, we've already found our x-intercept. Y-intercept, there is no y-intercept. The y is taken out because of our asymptote. So you can just put none or not applicable or something like that. Yeah, that's good here. So I graphed 1, 2, 1.26, 3, 1, 2. I'm not graphing all the way because obviously then I need to be this is very approximate. So I'm just graphing a little bit, but obviously this will be going down so much that you literally can't see it at some point. And then this side, obviously, I just put that much because if we go further, then more of the points, I need to be more accurate with it. So yeah, that's good. So that was a general gist of the graph. And so your average rate of change, that's your stuff that you do the slope with. We got 1, 3, so 1, 0. So 0 minus 3, that's 2. Then you've got 1 minus 3, negative 2 over 3, also known as 2 over 3. Just going to put that to signify it more. So that's good. Now end behavior, always you do the f of x here, x, and then so f of x, where is the x going? It is in the direction of the 0, and then it's going down, so that's your negative infinity. And then you have here, it's going this way, and it's going right and up. That's your infinities right there. So that's how you do that one. Hopefully you can see this one better actually. I'm just going to put this down again. So I'm going to do the next 2, and hopefully that should be some good practice. And then there's some other question that I think I'll do as well. Alright guys, I'm going to do this question here. I'm going to do this one, and then also we have this one here, which is using your natural log, which is also a good thing to practice as well. You have to remember when you're doing the natural logs, you have to use a calculator, a graphing calculator. You can use scientific maybe too, for using natural logs, because obviously you can't really calculate e yourself being a irrational number. So let's do log 2 3x. So basically here 3x, there is no minus h part, so your asymptote is x equals 0. Domain, that's your 0 to infinity. That's good. Always negative infinity to infinity, so I just put that out always. Your log is 2. Your log is 2, so here. So 2 is obviously, that's an increasing one. So that is 0 to infinity. Then we're going to put in the table 3 points. We have our points. We get already 2. They give us 2 with a 4 1/3, 2 1/3. So I'm just going to put those in. So what I'm going to do is it starts out at 0. Asymptote, draw that out. I'll do 2/3, 1, and 4 over 3. Because I get 3 points out of that. So 2/3, when we put that in, we get 6, 6, 2. So log 2, and then parentheses 2. That would be your natural 1. So this is 1 right here. So 2/3, 1. Trying to be as approximate as I can with it. Then 1, that's 3. Put that in the calculator here. So that's going to be, what you need to do is you multiply that, that's 3, so you put your log 3 divided by log 2 the base. So that's your change in bases, and then you get 1.58, which sounds pretty accurate so far. Always round to whatever place that you want to do it to. I'm doing it to hundredths. So 1.58. These might be two close points, but yeah, it's fine. So then we're doing 4/3. 4/3. 4 times 3, 12. 12 divided by 3. 12 divided by 3, 4. So log 2. Log 2 to the, then there's the 4. So that would be a second power. So that's 2 here, which sounds accurate as well. So 4/3. That's slightly over. Yeah, so it looks right. I'm just going to graph this. This is going to be very close. Yep, that looks good. So that's, I got the 3 points, and now we're just going to use them. So x-intercept we didn't find, so I'm going to show you the way to actually do that. Y-intercept, you can't get that because you got your 0. That's going good. X-intercept, yeah, let me show you. So what we have here, so what we do for x-intercept is you need to do it in exponent form to make it easier. I think I showed you in, I'm not sure if I showed you in a video how to convert this into exponent form, but I'm just going to that's another video that I probably need to do, but pretty simple process. You have log 2 3x equals y. Now there's this formula thing that you can use, or not a formula, but just a little bit of a cheat for this. You have your left, right, middle. Left, that's your small 2, that's your number for your exponent. Then you got your right, that's your y, and you got 3x here. What you want to do though is you want to isolate your x so that you can find out your x-intercept. So yeah, you just divide the 3, divide the 3. That's how then you cancel this out. You got x 2y over 3. Then obviously your y is 0 because it's an x-intercept. So you just put in a 0 there, 2 to the 0th power. That's 1. 1/3, that's your x, 1/3. And you can actually see it in the graph as well. 2/3 is here, so then 1/3 sounds pretty accurate. 1/3, 0. That's how you do it, coordinate form always. So all that's good. Then you got your arc there to do, which is your average rate of change using the points. So y2, 4/3 you're going to use, so 2 minus 1 over, then you got to do 4/3, 4/3 minus 2/3. Yep, then 1, 2/3. 3/2. So 1 divided by 2/3, just flip over the, you think of it as the reciprocal, you flip over this 2/3, becomes 3/2. That's how you get your arc right there. End behavior, simple process here. I'm just going to write it out. So actually no, you can't see the graph. That's important. So what we have here is we have the so it's going towards the 0, so that's what your x is. Your domain is your x, and f of x would be your range kind of thing. Your range is going down, so negative infinity because it's going downward. Then these, you have it going up and you have it going right. Those are two of your positives. So positive infinity, x infinity. So that basically means it's going right infinity forever and then going up infinity forever because, these are just lines.